Okay, this is an interesting problem. I really liked it, so I'm going to walk through how to do it. An unknown metal, M, forms an ionic hydroxide with the formula MOH2 that exhibits the equilibrium. There's the equation for the equilibrium in a saturated aqueous solution. If the solution pH is 10, the solubility product constant, KSP, of the compound is what? Okay, so this is one that we're definitely going to have to do math about. We're going to need to have a KSP expression because they have it here. They give us this pH of 10, and then they also give us the equilibrium expression. And that's all the information they really give us. So we're going to have to use that information to figure out what the KSP is. So I like to start all of these problems by writing out what the KSP expression is. So I'm going to do that first. So remember, the KSP is going to be the products over the reactants, the product of the products. Yeah, the product of the product over the products of the reactants. So we have on the product side, we have the concentration of the 2+ metal ion times 2OH minus squared over the reactants, M, concentration of MOH2. Does that look right? Should equal KSP, right? That's definitely wrong, and the reason that's wrong, let's take a look. Get the red pen out. So the first thing we want to notice is that this coefficient, when we're doing just a KSP expression, we don't use it twice. So that gets crossed out. Then the next thing is the reactants are solids. Solids are not included. Okay, so what would the correct KSP expression be? Well, KSP is going to have to equal the concentration of the metal ion times the concentration of the hydroxide ion. Now that is the correct expression, so let's green light that one. All right, so that's the correct expression for KSP. And we need to figure out what this is and what this is so that we can multiply it to find KSP. So are there any hints as to what we can do? Well, they tell us that the pH is 10. What does that mean, the pH is 10? Well, the pH tells us what the negative log of the hydrogen concentration is. So we know that the hydrogen concentration would equal 1 times 10 to the negative 10th. But that doesn't really help us because we need the hydroxide concentration. So there's a couple of ways to do this. You can find the hydrogen concentration first and know that those two multiplied together, hydrogen times hydroxide, has to equal the 1 times 10 to the negative 14th of water. So that would give you 1 times 10 to the negative 4th here. Or what I like to do is just change the pH to POH. So 14 has to equal the pH plus the POH. So if the pH equals 10, that means the POH equals 4. So the POH, and I understand I'm doing more things than would be necessary, but I'm just explaining this. POH equals 4, so that means the hydroxide concentration, just like we could look at the pH and get the hydrogen concentration, we can look at the POH and get the hydroxide concentration. So the hydroxide concentration must be 1 times 10 to the negative 4th. And that matches what we found up here using the alternative method. So let's green light that. We know that's correct. POH. Now, so we know now what the hydroxide concentration is, and that is one part of our equation that we need. That gives us this portion. But what do we do about this part? If we look back, let's see, if we look back to the equilibrium expression in the question stem, we can see that there are twice as much hydroxide ions in this solution as there are the metal ion. So we know that there's actually half metal ion concentration and compared to the hydroxide concentration. So this would have to be, so if this hydroxide concentration is 1 times 10 to the negative fourth, then the hydroxide or the metal ion concentration must be 0.5 times 10 to the negative fourth, because it's 1/2. And now we have everything we need to calculate the KSP. So let's rewrite that down below. So the KSP must be equal to 0.5 times 10 to the negative fourth times 1 times 10 to the negative fourth squared. So I'm going to go ahead and move this exponent. I'm going to say that's 5 times 10 to the negative fifth multiplied by, and let's go ahead and distribute our exponent there and there. So that's going to give us 1 times 10 to the negative eighth. And then we're just going to multiply that, and we're going to have 5. 5 times 1 is 5. And then in order to multiply our exponents here and here, all we have to do is add the exponents. So 5 times 10 to the negative 13th. So the answer, so KSP must equal 5 times 10 to the negative 13th. And that's your answer.